Cool. Yeah, maybe. So, so this is our first preliminary meeting for the semester. So for those that don't know, my name is Kevin. I'm the president. I founded the club. The club is a Software Developers Association, aka SoDA for short. We don't sell soda, but it's a nice name. The treasurer is Victoria. We have our officer Sam and Isaac, as soon as he does nuts and bolts.
Next week, man.
Yeah, soon TM. Yeah. So the goal is for this semester is revolved around game and mobile app development. Last semester we did a lot of backend and using like Node.js, and then getting some exposure to Xamarin Studios to do some native development. My experience with Unity has been like very positive. You know, I'm almost like an unofficial evangelist to this thing because I think Unity is incredibly powerful. You can do many things. It's not just limited to gaming. So if you think, oh, I'm not interested in gaming, like I don't want to do that, that's fine. But Unity is a lot more than just games. At this point, it's even being used to make short films because of the fact that you don't have to re-render your scenes. Everything is just done in real time. And as GPUs become more and more powerful, we have the ability to now have ray tracing in real time. So that's a big push that NVIDIA has been doing, and so is AMD. So we can get very accurate lighting. And that's very important if you're going to have a short film like you want to have Toy Story. Lighting is very important. This what gives inanimate objects something to look more three-dimensional. So yeah, there's a bunch of directors. I think the guy from District 9, if anybody's seen that movie, he actually made a short film. And in fact, we can just quickly look at a video. And it's pretty mind-blowing what you can accomplish. And this little short, it's called the Heretic. This was shown at GDC this year. This is using only Unity technology, so there's no custom shaders, none of that. This is just using pure Unity with its new rendering pipeline, taking advantage of ray tracing. And honestly, it looks so nice. So let's just watch this real quick.
This is the place. Doesn't look like much. Go take a look. Yeah, got it. Okay, here we go. So who exactly is this guy? You're kidding. They're a fairy tale buster. Don't be an idiot. Open it. Wait. This makes no sense to me, Buster. But you might have me right.
So, as you can see, the things you can do with this is incredibly powerful, right? Obviously, that's with a team of like artists and stuff like that, but all that technology is at your fingertips. So don't see that and think, oh, I can't do that. You can. In fact, the thing I love about Unity is when they make these little demo reels or whatever, they actually give you access to the entire project. So you can actually download this entire project and just start tweaking and see how they did the entire thing. So we can actually just go Unity, the Heretic project, and I'm sure you can find it on GitHub or something like that. So this is their, you should be able to download it. So these are all the other ones that they've done, all the other sizzle reels. So obviously the latest one would have been the Heretic. I'm not sure where that's. What's that? What happened? Oh, I don't know. I'll just click that one. So you should be able to have access to it. And for any of you guys that are wondering how this face was actually done, this is actually a process known as photogrammetry. And it's something that I'm actually really interested in showing you guys how to do. The only problem is you need a very powerful GPU. So
is that the same as motion capture or different?
Different. Motion capture records in 3D space, just movements of like certain, usually have like a bodysuit, right, and it has a little tracker, and you have all these cameras that are tracking your movement.
This uses like light.
So this is just a series of photos. I can actually show you how to do this just using your phone. It'd be nice to be able to do that. The only thing is I don't have a GPU powerful enough. Like having like a Titan X would take you like maybe 45 minutes to render something out. So and it's only available on NVIDIA GPUs, particularly the open source project that I want to use. It's called let's see, I think it's called Mesh open source. It's like Mesh something, Mesh Lab, not Meth Lab, but Mesh Lab. So this is it this one? No, it's not this one. It's called it's the Mesh open source photogrammetry. It's Mesh something. It's by this company. It's based off their machine learning framework. So this allows you to take photos and it'll generate a mesh and it'll generate textures and give you all the lighting data. So you can get a one-to-one representation of whatever. So if you wanted to scan a face, you could do that, hand it over to an animator, and then they can rig the face to start doing facial animations. So if you've seen like movies where they have all these little dots and their cheeks are moving, you can retarget the actual structure of the face to get that. So as you saw in the little video that we watched, his face, the entire thing is warping, it's moving. All that's animated, and all that's in control inside of Unity. So you can learn how to do all that stuff. I mean, look at this tree. This tree looks real, right? But it's a 3D scan. All these things are 3D scans. Mushroom, that's what it's called. So you can download it. It's right in GitHub. Let me see. We'll just go here, and it should tell you what are the system requirements. So we just need to have where is it at? Somewhere in here. It'll just tell you where is it at? No, just click right here, Mushroom, and Okay. Where's the rest of the stuff? Why keep sending me here? But yeah, I can link the documentation for this, and it just tells you that I think it should be this one, the manual. Yeah, here we go. It will tell you that you need to have an NVIDIA GPU. Go next. But yeah, oh, here we go, requirements. Here we go, GPU, an NVIDIA CUDA-enabled GPU. So those are pretty powerful. So you can use an AMD because they use the CUDA library to be cross, platform in a way. This needs to be updated to use OpenCL. We won't get into that, but yeah. So this only works on Windows and Linux. I have a Mac, but I have Windows installed, so we could do it. So if any of you guys have a GPU that's powerful enough and wants to bring it in, we can totally do it here. Yeah. So yeah. So that's if you want to do something more photorealistic. So, but we gotta walk before we can run, right? So, or crawl before we can walk. So, during the winter break, I think it was like last week, I wrote a little game just to give you guys an idea of what we're going to try and do. So I have an older version of Unity on this one. I built it on my Mac, but to drive the point home, I'm going to open it up in Windows, and it's going to work.
Hey, Kevin, do you know what is that game? It's like Cyberpunk. Was that made in Unity? Because it kind of looks similar to that video you showed.
Right? No. So it wasn't. I don't think so.
No.
No.
Don't they have their own?
They probably CD Projekt Red, I'm pretty sure, has their own engine, and it probably built for open world RPGs like The Witcher and stuff like that. A lot of companies, when they have the money, they'll build their own game engines to focus around the genre of game that they're going to use. Could Unity do it? Sure, but there's going to be some problems that you're going to probably face, and you're going to have to overcome. Yeah, for example, a really good example of engines that are not built for a type of genre but are still used is like the Frostbite engine. So the Frostbite engine is actually a fork of the Unreal Engine, Unreal Engine 3. And so EA has Frostbite engine, and the Unreal Engine is actually built for like first-person shooters, third-person shooters, right? Not meant for anything else other than that. Like, it's built around that, so you have a bunch of tools for it, but then you have a company like EA that wanted to use it, like, for example, Mass Effect Andromeda, and we all know what happened there. It's not meant to be an RPG. It doesn't have any way to do the whole dialogue system. It's not built for it. So Unity is a lowest common denominator. It's a very general solution, so you can accomplish a lot of things with it. But you need to know ahead of time, okay, what kind of game do I want to make? What are my tools that I have at my disposal? And what are the pros and cons? So I'm not going to stand up here and say Unity is perfect. No, it's not. Depending on what you're trying to do, you should probably use something like Unreal. Maybe use Crytek. If your game is heavily revolved around terrain, then use CryEngine. Don't use anything else, because CryEngine has been built specifically for terrain stuff. It has the best looking terrain of any game engine out there. Unreal has really good support for first-person shooters. I mean, Fortnite is built on the Unreal Engine because it's built by Epic Games, right? Epic Games is the one that built Unreal Engine. And it runs great. It runs even on your phone. Why? Because that entire game is basically a first-person shooter, and with using an engine that's built for it, right? So what I did was I built this little game just to give you guys kind of like what you can do. And it's called Maze. It's a little maze runner. Called Maze Runner 2020. Yeah, and so a lot of the patterns that are used are things that I want to go over. But this was just a little demo of what you can do in Unity. I built this in a course of about a week. If you don't believe me, I can show you the GitHub, and it just literally just has like a week's worth of work. And yeah, so this UI is implementing a pattern known as MVC. We have some music playing. Just turn that down. Don't really need it. But yeah, so we have some music playing. So that's pretty cool. I have this UI. I don't have it animated, and I have time to animate it. I have this little dialog. This is for like debugging purposes, so I can see what's my frame rate right now. So as you can see, I'm getting a solid 60 frames, and I have this little debug message here so I can see any logs, because this is for debugging purposes right now. So another thing that a lot of people tend to look over when they're building UIs is actually localization. So localization is having language support for different languages. Just because you're in the United States and everybody speaks English doesn't mean somebody may not feel comfortable just speaking English or can read English. Maybe they're better at reading in Spanish or whatever. So that's not up to you, right? You should leave it up to the person playing your game. You try to be increase your market, right? You don't want to just narrow it. Try and increase your reach, and the best way to do that is through localization support. So here, I have that, and this is using what's known as an observer pattern. And the reason why is, just look at the UI, and as soon as I change the localization type, so right now this game supports 4 languages: English, Spanish, Russian, and Ukrainian. So if I switch it to Spanish, everything just changed right there, right? And if I hit the escape button, the main menu changed as well, and there's no reload, right? It's just done automatically, right? Auto-magically, right? But I've rigged it to do this, right? So it's not, magic, but it's just using simple patterns, and it's very, very easy. It's very, very powerful. In fact, we can go ahead and I can just show kind of like how I designed this, and so this is an MVC pattern, is a model view controller. So this is my view, and I can just, from here, I can just start changing things, right? And if you can see, it's changing, right? So there's nothing I'm hiding. So it's pretty cool. So I have a little main screen. There's like the credits. So I built it, and then Victoria helped me, and then translations. So if they're wrong, the Russian stuff, you can blame Evelina. She's right there. Yeah. So I'll switch it to English, and as you can see, I have these little debug messages right here. So it says lang change to Spanish or whatever. So we'll go over what all this stuff means. And so the way I'm generating the actual maze, as you'll see in a second, is I'm generating this in real time. So I'm using what's known as a breadth first search algorithm to actually generate my maze. So the maze is actually what's known as a perfect maze. So from point A to point B, there will always be at least one path to get there. So it means that my maze, there's no way if you have a target to tell a player to go over there, you will always be able to get there. You won't ever be able to get stuck.
So it's different every time?
It's different every time. So here's the maze game. So you use your arrow keys, you move around, and there's a clock, there's a timer right here. So you start off with 30 seconds, and you try and pick up these little pellets, and you get points, right? And that's kind of the idea. So it's very basic, but the amount of detail that actually goes into even build something as simple as this, there's a lot of engineering that goes behind it. So here I have a little power up. So I even have a state. So I can hit this, and now I'm in this purple state, and now I can eat the little red guys, right? If I don't do that, I lose points. And as you can see, there's the timer's going red because I ran out of time. And now here's my game over screen. So I can hit retry, and the maze is different. And in fact, if I go over here to my maze maker, I just keep hitting generate, and it just keeps changing. right? I can have, so the replayability behind this is like basically infinite, right? I just, do whatever I want, right? So that's pretty cool. I have this pause screen here to actually pause the game. I can go into options, and I can bring back that options menu I made. Because there are no dependencies between the menus. They live separately. You just tell somebody, hey, can you open up? And then it'll open up and it has its own controller. So even here, while I'm here, I can actually change this to Spanish. I go over here, look, my pause is now in Spanish, right? So I don't have to do like, oh, let's go to the main menu first and then change it there because there's some dependencies for whatever reason. Here, everything is totally like not spaghetti code, as you can say. So I'll say quit. I'm in the main menu, and look, it's still in Spanish. So that's pretty cool. So yeah, that's basically the game that I made. It took me about a week. And yeah, it works pretty cool. It's actually pretty fun once you start playing it. It's actually kind of addicting because the game is very, very simple, but yeah, I wanted to throw up on Athena so you guys can play it using WebGL, but I mean, I might still do that. But yeah, the game is quite addicting. I go in to test, and I'm there for like a good 5-10 minutes just playing. I already did all my testing, but I'm still playing it. It's really fun. I have this on GitHub, so I'll link it so you guys can actually download it, open up in Unity, and just look at all my code, right? So in fact, let's look at some stuff that I think some good highlights. So let's look at the UI, the way I built this, just so you can see. So everything is very organized, right? And that's something that I can't stress enough is when you're building projects like this, organization is like a must. Chances are you may not be working on a project by yourself. So if you have a specific nomenclature that you have for whatever reason, make sure that it's shared between the entire group. Naming conventions, stuff like that. Folder structure. It needs to be consistent so you don't have to, get lost in your folders and be like, where's this module at, right? You could figure it out just following the structure. So here's and a lot of this code is actually kind of barren. There's actually not a whole lot going on, but it's because everything is stacked on top of each other. When you bring it all together, it's like an orchestra. You have little instruments, but once you put it all together, you have like the symphony, right? So that's kind of the idea behind software engineering is you shouldn't have monolithic scripts or monolithic code. You should have little pieces, and then you just put them all together, and you create your entire system. So this only has like 50 lines of code, and the majority of this is for the localization stuff. It has nothing even to do with drawing or what the UI does, not much. So we can go over here and let's look at what the menu looks like. So the menu has about 50 lines of code too, so there's still not a whole lot going on. And again, this is all done on purpose. It's not like I'm not writing stuff, as I am, but everything is cohesive, everything is going to work together. And then I have a thing called a controller, and even this has even less code, right? So as you can see, as I'm going up in this hierarchy, I'm using, some some inheritance here, right? The higher up I go, I'm actually writing less and less code, right? Because everything beneath it is doing its job. Everybody has a job. So let's look at an example for like the main menu. How does this guy look like? So let's look at the view. The view doesn't do a whole lot. There's a lot going on here, but it's really not doing much. I have this update localization method that gets invoked, and this happens when the player changes the language, right? I need to tell the view, hey, you need to update yourself because something has now changed. The localization has been changed. This gives the ability for the view to be like, okay, what needs to be updated? So I use a thing called phrases. So the phrase, like the word play, I call that to be a phrase, so that's called play. I leave it in English because I built it, so I speak English, so I use English. You can use whatever. And I just look for this phrase inside of my localization database that I have. And if it exists, then I get what's known as the locale. The locale will be the actual phrase translated. So I look for it, and I find it, and here's my button, the play button. I go in, I find the text component, and I just update the text. So it's not rocket science, right? You just follow this, and it's like everything just makes sense. It's like, okay, find the phrase, find the specific translation, update the text, and I'm done. And I just do this for every button. And the view has no logic. Besides the localization, the view actually has no logic. It just has, I guess you can call pointers or references to everything that the view has. So we can just look at the view here. We have our buttons. We have 4 buttons here. The play, score, options, credits. The view has these buttons. The play, score, options, credit, and it has a menu button. That's this menu button. It has a text called header, and that's what this guy is right here. That little header, right? And that's it. Right, so the view's not really doing much either. It just holds references. Now let's look at the controller. Now the controller, now we're getting into some stuff, but even then it's not a whole lot. The controller hooks, basically, what we usually call the model with the view. Okay? And so the controller basically controls the flow. All right? And one of the main things that the controller here does is when you click a button, the controller will actually handle the button clicks. So you can see here I have these methods called attach and detach. So attach is when the view changes. Attach yourself to the view, right? Basically add listeners to all the events possible on that view. And just notify me when something has been clicked or something has happened. And then the controller will take care of the business logic. So you can see here I have this on-play event. So this on-play event is registered with the play button. So when the play button is clicked, invoke the on-play event. When that happens, what am I going to do? I'm going to load the scene called game. That's where my game's at. And that's it. All right, so it's not that complicated, right? It's just, again, it's organizing the flow, the control. And this is all using design patterns. And look, there's not a whole lot going on. And that's beautiful, right? So by having this, by doing what's known as a separation of concerns, you're moving code to just do specific tasks. You prevent having spaghetti code, strong dependencies, and it also allows you to better handle changes later on. For example, let's look at this view. Suppose I have this for a client. The client says, hey, can we move these buttons around and yada, yada, yada? I can do that. And it won't affect the core logic of my stuff because the view handles view stuff, right? If I want the buttons to look different, that's not going to have any issue with the actual buttons being clicked. That code should be separate, right? The way a button looks and what happens when it gets clicked should not be in the same file. Now, suppose they were. Changing the look and feel of a button with the logic of clicking can cause bugs. It's possible you can mess something up, especially if multiple people are working on the same file. Right? It's possible this can happen. But by having the separation of concerns, you can have your artist, your UI artist, work on the view stuff, and then you know that your core logic is safe, right? Because you have this separation of concerns. Okay? So yeah, so that's kind of like an overview of like this little game. Does anybody have questions about this or anything like that? So.
So, model view controller.
Mm-hmm.
Just can you go over? I know this is important.
Mm-hmm.
The model is like
your data.
the data. The controller is like the logic.
The controller handles the logic mostly, and then the view just shows you things.
Right. And so, what design patterns did you use here?
So for this entire thing is just straight MVC, and MVC has a bunch of patterns inside of it. One of them is the observer pattern, right? And that is the basically observable It's when you subscribe to something that could potentially change, and you just want to be notified of that change so you can do something. So you can't actually tell because it's kind of buried inside in the view, actually. But I actually have that going on. It's actually happening right here. Right? So my model, there's a shared model between all these views, and that's actually this thing called app data. So let's go inside app data. Oh, that's not what I wanted to do. Let's go to definition. Here we go. There's app data. So app data here is inside of data manager. Data manager, I'm using a singleton pattern. So that's another thing we're going to learn is about how to use a singleton pattern. So let's go inside this guy, and here we go. So here's my app data. My app data has a string, right? And it inherits from a class I built called observable. Now, what is this observable for? Well, let's go inside there. And so here we go. And so this has a lot more code than you've seen, and it does a lot. Okay, it's very generic. We'll talk about generics, but it's also very. It doesn't care what the data type is. It doesn't care, and the reason for that is because when you subscribe to a property, because I'm taking advantage of properties in C#. I can, if a class implements the observable pattern, I can just say, hey, let me know when this string property called blah changes. And then when a change occurs, it'll notify you. So, for example, here we have this, so let's go back to the, where is it at? The app data. Here we go, app data. So here, inside of my view, yes?
Or do you have this like online for us to look
Yeah,
at?
I have it in GitHub.
Oh, you-
So yeah, all this is open source, so you can just play around with it. Yeah, yeah. So here, we'll go over what gets and sets are. But when I change the language here, this little thing happens. I call on update lang. Lang is the property name lang. I just pass in that new value, right? And if something did change, I just do a quick little debug log. You saw that on the screen. Just says, hey, the language has changed. But during this, inside of here on this update, if we go inside of here, oh, it's actually here. On this update, if the property actually did change, it's going to notify everybody that will subscribe for this change, right? And here's the notification. It's going to go through all the listeners and let everybody that was listening be like, hey, something just changed. And that's how the view is actually able to update. Because I just tell it, hey, when this thing changes, let me know. And what happens? I call the on localization update, and then the views just change. It's beautiful how it just all meshes all together like that. Right? It's very nice. Right? And that's just an example of the observer pattern. And the MVC uses that. We have our views here. So let's go to the right here, the main menu view.
What?
Remember
Model view controller.
133.
Yeah.
We learned it in 131, but didn't actually
Yeah.
learn it until 133.
Yeah. You probably won't use it until 133, because that one revolves all around a lot of programming.
I have the Apple 131 to make you really want that shit.
Yeah. It's powerful. I mean, look what I was able to do with just hooking this up for like localization. It worked beautifully, right? And the view here, we can subscribe to button clicks, right? So when the play button gets clicked, I showed you that code too. When the play button gets clicked, that's an observer pattern, right? You're observing. You're waiting for that button to be clicked. In fact, a lot of the things that Unity handles is actually event driven. So it's nice because you don't actually have to poll. So you save a lot of computer cycles by just having to wait and listen. You can just say, hey, call this method when something happens. Let me know. So that's really, really nice. And one of the drivers here is the data manager that I have is using a singleton pattern. That's very, very popular. A lot of people sometimes say you shouldn't use it, but I think if you know how to use a singleton pattern correctly, it makes your life a lot easier in certain aspects. The singleton pattern basically forces only one instance of a particular object to ever exist in the application's entire lifetime. In fact, I think this is so important that I think I commented the entire thing. No, I did not. I thought I did. Well, I don't know. I forgot what. Oh, yes, because I actually. Yeah, it's here, but I was actually writing a little documentation on GitHub, doing a bunch of patterns, and I was actually doing all that. I thought I commented this, but I didn't. But yeah, so here's an example of a singleton pattern. So there you go. Boom. Right.
Hey Kevin,
Mhm.
not to interrupt, but I know you made this, and like you're a great programmer. Are you planning on like having all of us go through this same project?
That's up to you guys. If you all these patterns that I used, I'm going to show you, and because we're meeting twice a week and it's going to be 2-hour sessions, I want to go through all these patterns, but also with examples. So we'll do an example. We'll learn, like, for example, the singleton pattern, and then put it into practice. And that way you guys can get a good idea of, like, okay, I have an idea of when I should probably do a singleton, when I should implement MVC pattern. MVC pattern is not just for UIs. It's whenever you have this need to separate views from data and logic. You can have a character controller implement an MVC pattern. Why not? A character has data. You have the view, which is the graphics, and the controller would be all the logic, how you move the character, how the character dies, how it power-ups, stuff like that.
What about, say, I don't know, VR planetarium?
So if you want to do something like that, because I know that's your senior project, if you implement software patterns, you could make it where if you ever wanted to make new changes or if you wanted to add new features, a lot of it would just be plug and play. Very little changes to the code. That's what you want to do, is you want to minimize the amount of code changes you actually have to do to minimize the possibility of you actually breaking something. That's your main goal, which is kind of like odd because as a software engineer, you want to write more code, but at the same time, you kind of don't, because you want to keep it simple and keep it straightforward and make it really, really powerful and as fast as you can. Sometimes, that's a balancing act. Sometimes you can, sometimes you can't achieve that. So my goal is to show you guys these patterns. And the reason why I'm using Unity is because we can actually deploy to our devices. For example, right here, I'm in Unity right now. What am I in? My build settings. Okay, so right now I'm currently under the standalone build. So this will actually build a Windows project. So I can tell it what kind, x86, 64. Go to my player settings. I should have this set up. Other settings. Yeah, so I have all this. So I can just go here and hit build and run. It's going to ask me where I want to put this. So I'll just create a new folder called build. And then go inside. Call this Windows. So I can separate in case I want to also build to Android and stuff. I can separate all these things out. Hit select folder, and then now it's going to make me a Windows build. So now I just wait. Well, I'm recording, right? And so this will actually make a Windows build. So instead of having to open up Unity to run it, I can just run the executable and run it there. So I can actually take this, put it on a flash drive, put it on another Windows computer, and then run my game. So that's nice. And in fact, if I want to switch this over to Android, I can just switch to Android and then build to Android, and it'll run on Android. It won't work because I don't have any support for like a touchscreen yet. The UIs will work, but I won't be able to move the player. But we add that, and then we can. So So that's the beautiful thing about Unity is that you can target any platform you want with almost little to no effort added, right? As long as you build things ahead of time, thinking about cross-platform, then you should be good to go. There's not a whole lot, and Unity does you a big favor of that. They constantly have support for this, obviously. Patches, bug fixes, and stuff like that, and they're constantly adding new features. That's why I chose, or I'm going to choose to stick with 2018, Unity 2018, because they're always coming out with a new version, you know. So there's 2019 right now, and there's also 2020 coming out. So we'll stick to one, right? Learn all of its features, and use that to build our projects. And then if you guys like it, you guys can look at a newer version, and it's going to have new features and stuff like that. So this is going to take a while because I'm recording. No, it's not frozen. It's just it has to compile all these shaders, and then it'll do it. Alright. So yeah, does anybody have any questions about any of this? Okay. So what are you guys interested in like learning? What do you guys want to do? VR? We can do VR. We can totally do VR.
I think so. Just in terms of like side project, I don't have that many good side projects, and I think as like a result of this club, like it looks really good if you have a side project with NPC and like design patterns on your resume that's not from something you did in school.
Mm-hmm.
So I think for me as a result of this, I would like nothing like it doesn't have to be the greatest thing in the world. Like it could just be like a simple like screen where you fly around.
Yeah, like that maze game.
Yeah, exactly.
Yeah.
Even without the maze, just like walking around.
Yeah, we can totally do that. Yeah, we can do a lot of things. We can do like another. We can do like a Flappy Bird clone, right?
Yeah.
We can do that. We can even do it where we actually, you know, it'll be more advanced, but maybe we can add it in. But we can actually, using a neural network, actually teach the AI to play Flappy Bird if you want to. Maybe even fly, drive itself. I mean, there's a lot of things we can do. Unity now supports known as AI agents that have like this entire framework built inside using neural networks. So you can actually build AI inside of Unity a lot faster. So I'm going to play this at a very low resolution. Let's go with that. Do it windowed. Right, and yeah, so this is using an actual build, right? So this is not through Unity. This is now a Unity game, right? So there you go. So everything's working as it should. We have all this stuff. Yeah. Let's see if it's right. Where's my Russian? Oh, he's gone. So there he goes. Whatever that means. We have Ukrainians for the ones that speak Ukrainian. So yeah, so like I said, it's pretty dope, I think. And yeah, to your point about like create something simple. That's why I had built this. If people like the way this game worked, we can totally do that. If anybody has another idea, I originally was just going to do tic-tac-toe.
So
We might just do tic-tac-toe.
this isn't like for me. This is overwhelming. Like there's no way I'm just gonna sit down and do this.
Mhm.
Like you did in 133. It was like you made something that's really simple. Is that how you?
Yeah, we're not gonna build the entire thing
Okay.
like in a week. We're gonna just build pieces at a time, and by the end, we'll have basically this entire project. If people choose to do this. If not, we can always do something even simpler, like maybe have like a little shooter where you have like these little targets pop up and you just shoot the targets. We can call it shoot the target. Yeah.
Something that encompasses like
Grid breaker. Yeah, we can make Tetris for the ones that like Tetris. Tic-tac-toe. I originally wanted to do tic-tac-toe because I thought, oh, that'd be interesting. We can do tic-tac-toe. It's cooperative, and I can introduce multiplayer. So you can have tic-tac-toe multiplayer. So you can have like two Android phones, an iOS and Android phone playing tic-tac-toe, over the network. right? It's very basic, right? But there's a lot going on, and once you have that, at least a small foundation, some exposure, you can take that to the next level and do something even more complicated. Because there's a lot of things you can do, and it's just, yeah. So whatever you guys want to do, we can totally do that. If you guys want to do some multiplayer, I think we should do tic-tac-toe. Because even then, there's a lot going on, even in a simple game of tic-tac-toe. If you do it right, we're gonna over-engineer a very basic game, but that's kind of the point, right? So it's a very simple game. Everybody understands tic-tac-toe, but we're just gonna over-engineer it, as if it was something super complicated, even though it's not. We'll just over-engineer it. That way, everybody gets exposure to all of these software concepts, and then throw in some multiplayer, and then hey, maybe we even add some AI, so you can play against the AI. You're playing tic-tac-toe against the AI. Right? So there's a lot of aspects we can do about this, right? So yeah. Maybe we probably should just stick to tic-tac-toe.
Co-op tic-tac-toe?
What's that?
I said co-op tic-tac-toe?
Co-op tic-tac-toe, yeah. Yeah, we do co-op. 2v2. I mean, there's a new Tetris game that has Battle Royale. We can do a tic-tac-toe Battle Royale multiplayer. Hosted on Athena, and then 3D tic-tac-toe. Right?
How hard is it to do the networking multiplayer through different phones or PCs?
Is that built in or is that something?
So there's built-in, and there's also third-party plugins that we can use. I like Photon. You can use Unity Net, Unity Networking, which is built inside of Unity. Or you can do it using raw sockets and just build the entire infrastructure, although that is not ideal. Because the thing about gaming, the reason why I like gaming is because, in my opinion, it's probably one of the more complicated parts of computer science. I've said this many times, because let's say you want to say, oh, we have this tic-tac-toe game. Now let's do multiplayer. Great. There's a lot. Just as saying multiplayer, there's just a lot going on. You have to understand sockets, TCP, UDP. What's the difference? Which one should you use? How do you build your matchmaking? You need to have a database, and now you have to build your backend for your database, stuff like that. Cheaters, stuff like that. So, are you gonna have a relay? Is it PvP? What is it? Or P2P? Yeah. So there's a lot going on. So it's quite complicated, but we won't go that route. If we do it, we're gonna use a package that I really like, which is Photon, and it does a lot. It does all that for you. It uses cloud technology, so all the logic gets thrown up into the cloud, and then we just get the results. Yeah, so this is like, because in Call of Duty, you can get someone's IP because they use P2P type stuff. There's a host and there's a client. That's why a bunch of swatting happens. In this case, we wouldn't have that. It would be a relay. You send a message to the cloud sends it to the client. So the only IPs, if you even have something like Wireshark sniffing the packets, you'll never see the other clients because you just see the server that you're talking to. It's a cloud server. So yeah, we can do that.
All right, bro. You get class.
All right. So this was just a preliminary, so we'll just cut it short. Next week, we'll have a room here somewhere. Forget the room. We'll have desks, so bring your computers, and then we'll just start with Unity. I'll put in the Discord chat what version of Unity to get. That way everybody's the same. So if somebody's broken, we can assume it's going to break everywhere, so we have consistency. And then I'll
Picking time because like every fucking class.
Yeah, 3 to 5, yeah. I don't know. I only have one class on Tuesday, or Tuesdays and Thursdays, and I don't want to stay here till like 6 or 7.
Figure it out.
But that's why I'm recording it, so for those that can't make it, I will throw it up on YouTube, and I will share that link. So
Do you have like a just basic like hello? I don't know what the equivalent of hello world is in Unity, but is there like some sort of a?
yeah, we usually, the hello world thingy would be just trying to get a sphere to like rotate. Or not, or like a cube, get a cube and just try and get this thing to like rotate like that. So you can just rotate it. So we can start off with that, because I still have to go over like all this screen has a lot going on, all these little windows, what these transforms do and all this stuff. So I'll go over that next week. Basically a crash course in Unity, And then we'll also need to learn C#, so we'll be doing that in parallel, all this stuff. So there is a learning curve, but once you get over that first bump, I think it's pretty straightforward from there. The documentation for Unity is like insanely good, I think. Not the documentation on the website. The documentation on the website is pretty good, but I'm saying like the community, everybody, asks some help. They're usually there to help you. So it's really nice. So if you ever get stuck, just Google it, and chances are you'll find it, because you're not the only one that had that problem. I guarantee it. Unless it's something very specific, I highly doubt it. Somebody had that problem, and somebody was able to help them. Or they resolved it, and they told you the answer. So, yeah. Stack Overflow is good. The Unity forums is great, because it's Unity related. So yeah. So hopefully you guys are excited about this. And then if you have an Android device, that'd probably be most perfect, because it's very easy from Unity to build straight to Android. If you have an iOS device, you need to have a Mac. You need to have Xcode. When you build to an Xcode project. You have to open up the Xcode project in Xcode, and then you build from there. You can't build straight. So there's a process for that. I can show you guys. So those that have iOS and have a Mac, you always want to build to Mac to iOS. I can show you. It's free. And on Android, obviously, it's free. So yeah. No, we won't be using emulators. We'll straight still to the device. Although we could. Like if you don't have an Android device on you want to use an emulator, you could. I don't recommend that. I think the emulator is Unity. That is your emulator. What you see is what you get, right? If you don't have a touchscreen, maybe you want to test out the touch stuff, then you maybe use an emulator, but even then it's going to be kind of like, janky at best, having an actual device, it beats any emulator you could ever use. So yeah. Just close this. So does anybody have any questions? No? All right, cool. So then that'll conclude the preliminary meeting today, and then on Tuesday it'll be again same time.